Hello, this is Michael Garino, and I'm going to give you a quick overview of how to use Plural Service Catalog to simplify complex self-service infrastructure provisioning tasks using Plural. Just before we get started, a quick bit of helpful context on what Plural is, because it'll be pretty useful once we see the actual nuts and bolts of what's going on with the Service Catalog provisioning. Plural is an end-to-end Kubernetes software development lifecycle. It encompasses a number of different subcomponents. The main ones that are relevant for the Service Catalog are our CD system, which is a enterprise-grade fleet scale continuous deployment framework built on top of GitOps principles. Think of it like an Argo CD or Flux CD on steroids, with hopefully we think a much better user experience. We also have Terraform management built in. This allows you to declaratively specify various different stacks pointing to Terraform source code located in your own Git repository, and creates a full development and deployment environment around that Terraform code. The key aspect of this is it's instantiable via CRD, so it can compose with the continuous deployment system that you can see right here. And the last major component is our pull request automation framework. The key thing that this does is it allows you to automate a lot of the code changes that are necessary with a GitOps and infrastructure-based strategy, which, while GitOps and infrastructure as code are really elegant solutions to the problem of infrastructure provisioning, actually does require a lot of manual effort, and manual effort has the attendant risks that comes with any human error related process. Now, just to give you an overview of the service catalog, this is basically meant to be a bundle of related pull request automations that accomplish a common goal. So we have, for instance, a bundle of Terraform data engineering pull request automations for the provisioning of a number of different common and very popular open source frameworks like Airbyte, Dagster, and MLflow. Airbyte's an ETL platform. Dagster is a job orchestration platform very similar to Airflow, if you're familiar with that. And MLflow is a orchestration platform for the operations around ML training jobs. There's a DevOps catalog that you can see right here for provisioning Grafana and KubeCost. We also have a infrastructure catalog with a EKS cluster creator. We have a catalog for security-related provisioners, like for OPA Gatekeeper, for policy enforcement, Trivia Operator for container image scanning. So as you can see, it's quite flexible. You can really deploy virtually anything you want with this framework. One thing that's also worth mentioning is these catalogs that you're seeing right here are maintained primarily by Plural. That said, it's meant to be able to be both forkable. You can fork our own catalog and craft it to your own enterprise's needs. You can also develop your own. So it's a completely open API that is very easily interactable via Kubernetes CRD or actually Terraform provider. And it's entirely natural and easy to really build as sophisticated a process as you want on top of the building blocks that we're providing you. Now, just for the purpose of this demo, we're going to focus on Dagster specifically, because I think it's a pretty interesting little application to demo the service catalog feature around. For people who are not as familiar with Dagster as maybe your average data engineer might be, it is basically a replacement for Airflow. So it's a batch job orchestration platform. Architecturally, it has a number of different components. It has about 3 main microservices, one of which is a web server, another of which is the actual worker deployment, and then there's a scheduler component to it as well. It will also fork Kubernetes jobs for each of the various jobs that it needs to execute. And then finally, it will have a storage layer underneath that's usually uses Postgres. It can actually use other databases as well. We will instantiate that storage layer via AWS RDS. The other important thing to mention with this, and this is common with a lot of different open source frameworks like this, is it doesn't actually natively support authentication unless you're using the cloud products. So if you want to have an actually secure instance of Dagster, you need to figure out some authentication layer put on top of it, either with like an OAuth proxy or something like that. We basically simplify that entire process for you. So you don't really have to think through any of the complexities of authentication. When we actually have this fully provisioned, you'll see the OAuth handshake happen. So just going through, we're going to go to the actual PR automation for setting up Dagster. It's a very simple wizard that's exposed to end users, so it should be something that can be, filled out by a baseline engineer and not someone who's necessarily an infrastructure expert. We're just going to give the exact region we want. We're going to give it a bucket name. And then we just got to give it a host name. And then we're just going to give it a branch to actually finally create this specific PR. And now that the PR is created, we can see the code that's been generated for us. This is all generated based on the templates defined for this PR automation. First things that you can see are a couple Kubernetes service deployments to actually instantiate this Dagster instance. So this is the deployment for a number of secrets necessary for Dagster. There's also a deployment for the OAuth proxy. One thing that might be worth mentioning is it does import from the stack, which we'll see in a second, the outputs of that stack. So you have the ability to compose data that's in your Terraform configuration natively with the Kubernetes CD and GitOps CD engine as well. And that can simplify a lot of the complexities around and manual effort that comes with a lot of this IEC-based provisioning. You can also see the Terraform code that's necessary right here. And then finally, the actual proper Dagster service is this right here. So this is actually instantiating Dagster's upstream Helm chart with the specific values file that we needed to write and a number of other basic configuration values. A couple attributes that might be worth mentioning here. One, there's a lot of possibility for post-hoc reconfiguration of this. So an engineer who might be interacting with this might decide that they need a different set of IAM policies for their Dagster instance, or they might need, different settings for their S3 bucket. That's very easy to do in a natural dev-friendly way because you have the code right available to you. So you can make a commit once this is all set up with a PR and then approve it. And you have a robust review and approval process and a really good process for post-hoc reconfiguration of these applications, which is a very common need. They're complex entities and they need to be delicately managed oftentimes if certain settings or certain features need to be tuned for the needs of your enterprise. Now, just to kick this whole thing off, we merged in a domain, but there is a slight sync interval that we need to go. So we'll just resync this service right here and get the whole thing fully set up. Cool. So you should just see the actual Terraform stack around Dagster starting to be run. Awesome. And you can see that the actual plan has been computed right here. We can also see a bit more of a clear view of the full Terraform plan in the plan tab. But this looks mostly okay. And I think we're just going to approve it to see it in action. Now this will take about 15 or so minutes for AWS, which is quite slow oftentimes to provision the database. We'll let that hum in the background and then come back when it's fully ready to go. All right, and you can see the database is finally finished provisioning. It took a little bit of time, but now that it's done, it's generated all its outputs. And if we go to the cluster we decided to deploy to, you can see the few services that it spawned to create that Dagster instance. So there's the AWS environment, the OAuth proxy setup, and that management cluster. And Dagster itself is converging to a healthy state. As you can see, this pod is in fact just reported as being healthy, and the entire service will report itself as healthy in a second as well. Now, while we're waiting for that, we can actually probably just go straight to this Dagster instance. So let's try looking at that URL and seeing what we get. And you can see it's doing that OAuth handshake for us. And then we're going to get back into the Dagster instance. So yeah, this is Dagster. Just to um, double check that everything's working as expected, we can actually go to one of the default jobs they have in their setup and try and run it. So go to their little Dagster launchpad, hit launch run, and we'll wait for it to actually fully set up. Cool. So you can see Dagster is doing a little bit of thinking, but it should be spawning that Kubernetes job, which it ultimately uses to orchestrate the compute workloads. And we have the job going to a halt. Yeah, so there you have it. Pretty simple, easy to deploy working assistant Dagster with just a quick web UI, all seamlessly configurable by your own platform engineering team or by just using our off-the-shelf catalog as well. If you're interested in learning more about what this could theoretically offer for you, or just want a more guided demo, feel free to contact the sales team at Plural and we will get you on your way. Thanks for tuning in.